This was straightforward. Starting, ending, to visualize it as a continuous, so a small interval, then is d gamma. This is, we have done this several times. You need to have the alpha and a scale factor beta. If you don't mention a scale, by default, R, consider it is rate. So it goes with lambda. Make sure we are using beta, so mention that is a scale factor. Now, estimate multiple parameters. First, I'm generating a sample using the true parameters. Alpha 2, beta 5, I'm generating a sample from that gamma of size 100, okay? Now the next thing, this is log likelihood estimate. I generated the function. Always you have one parameter here, but it could be a vector. Here, since we have two parameters, theta 1 is alpha, theta 2 is beta. And this is log likelihood. Since I have applied log, then the product turned to summation. And when we put log equal true, it means that in place of probability, it's considering log of the probabilities. So what is this? Here. This is basically summation of log of those probabilities. F of x, alpha, beta. Sum of log probabilities. What is the negative sign for? When we use optim, it does minimization rather than maximization. So, we would like to maximize this. It means that we minimize this. So again, optim, find the minima rather than maxima. To make sure that it's going to do the right thing, you see that minus here. Here is to make sure. So minimizing minus this, it means that maximizing this. Okay. Run the function. And then I use optim. Parameter, based on the number of parameters, you need to give the initial values. This is the initial values for my alpha, this is the initial value for beta, and my sample, which is x. Here, I generated. So, and I put it in MLE. Let's do this. All right, okay, what I have, now estimated parameters are in MLE. How to access it, come down here. MLE, $PAR, gives you the parameters which are estimated. 1.98, which is good estimate for 2, and 4.29, which is estimate of a scale of 5. How to access them? This index 1 gives you the first parameter, index 2 gives you the second parameter. Okay, you don't need for the first part since you are just going to estimate whatever way that you would like. So now you have the estimated parameters. You can feed the gamma function with the estimated values and plot it again. How? Here. I have estimate of alpha, estimate of beta. I put it here. Now I have the estimated PDF. Why estimated PDF? Since I'm using the estimated parameters. Those are not anymore the true parameters. So I generate this using the estimated parameter. You see, estimated alpha, estimated beta. And now I'm superimposing on whatever I had before with blue color. The blue is the estimated one, the black is the original one. If it's like this, so you need to play with the limits for x, for y label. So to do this, I go backward. Let me quickly do a plot where I plotted this. And I say y limits equal, I increase the mean and max for my mean is 0 still, but max since it's clipping, let's see, let's just go to 1, see whether it works. Oh, it's too small. So let's do it 0.2. Now it's better. And now I come down here and superimpose this. Now it's visible. So by while you can flexibly change the limits if it's clipped. SC.2 is I think I can have better. So you can play with that. Perhaps you can go even to 0.5 and you might be fine. Oh, no, I mean 0.1. And perhaps still we should be fine. Not bad, yeah. So those are the things that I would like when you visualize it, show it. I don't want that the plot be clipped from horizontally or vertically or whatever. And it's easy to fix it. So last thing, Monte Carlo. What is a Monte Carlo? If you do this estimation repeatedly, what does it mean? Generate a sample, estimate alpha, beta. Generate another sample, estimate alpha and beta. And do it multiple times. And each time, save the values. So what I have, here I have a for loop. Each time I generate a new sample and I estimate the parameters and I save them here in parameter estimate, which is a matrix. So if I run this, so and t is equal 10, I ask you to do it for 10 times as well, is the same thing. So you do this, let's do this. Done. Now what we have, if I look at my estimated parameters in that vector, so I have 10 estimates of alpha, 10 estimates of beta. Basically that was a Monte Carlo approach. I repeated this several times. If you are curious, it's better to increase t from 10 to 100 or whatever. I ask you to put a table of size 10 rather, but it's better to do it for larger values of t. What happened eventually? I asked for Monte Carlo estimation error. So you have several estimates. You need to find the mean of those estimates. It gives you the Monte Carlo mean of the estimate. What is that? For this column, just do the sample mean of these values. The same thing for this one. It gives you the mean, Monte Carlo mean for alpha, Monte Carlo mean for beta. Second one, Monte Carlo standard error. What you do? A standard deviation of this one, a standard deviation of that one. Now you have the Monte Carlo mean for alpha, Monte Carlo mean for beta, Monte Carlo standard error for alpha, Monte Carlo standard error for beta. What is the function? SD, SD. SD applied to this, SD applied to this. For a standard error, mean applied to this, mean applied to that. I'm posting this. 90% of the code is already there. Yeah, you don't have excuse. But I would say that play with that. Visualize it and make sure that you have a good understanding. I wanted to go through that before